Okay, good afternoon all. Hello everyone.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. Good afternoon. Okay.
Good afternoon, sir.
Good afternoon. So yesterday I discussed about the very basics of computer system and its applications, and I also discussed about various components of a computer system, or you can say the basic architecture of a computer system, and I discussed about the little bit about the hardware and softwares and various kinds of softwares, various types of softwares. And in our lab yesterday, we discussed about the flowchart and algorithm, and we have done some problems with the help of our Raptor software. Okay, design and analysis of the flowchart. Now today, I also want to continue. I would like to continue with the discussion of regarding the basic architecture of computer system and its memory architecture, storage of a computer system, and then I move on to the discussion about the operating system. Okay, which I have just started in the last class. Just little bit of discussion I have ended in the last class. So before I'm going to start today's discussion, I want to just ask you if anyone has any sort of doubt, any sort of questions regarding last class, then you can ask me. I'm open for the question. Okay. If anyone has any doubt, any question, you can ask me, or I will start with the discussion. Anyone has any question, any doubt regarding the last class? Yes, you can ask about flowchart part. What is the doubt? Shrideep Bhomik.
Yes, sir. Sir, I cannot do the factorial and Fibonacci, these two questions.
Factorial and Fibonacci.
Yes, sir.
Factorial and Fibonacci, these two are the most tricky questions that I have given in the last 11 assignments among them. In factorial, we can find the factorial of a number. That means the input of your flowchart, or you can say of your algorithm, will be any integer number. For sake of simplicity, we will consider any integer number. Integer number means any real numbers. Okay, 0 to 9, and you are going to trying to find out the factorial of that number. Okay, so if I'm going to I'm trying to find a factorial of 5 factorial, then the
Sir.
logic. Yes.
So factorial's logic, can I try once? I have done it.
Yes. You can tell me what logic you have applied.
So like if we want to find out the factorial of 5, then we have to the calculation part will be 1 into 2 into 3 into 4 into 5. So if we take a loop from 1 to the number that we have given, and then in the functional part, in the product part, like suppose P is equal to the product, then P equals to P into if we take I and then increment it with 1 up to it reaches N, P into I at every step until and unless it reaches N.
Right. She has done it correctly, that she wants to tell that our main logic should be like this. I'm not showing you the flowchart part that you will do by yourself. I'm just what she told. I'm just explaining that thing. Shrideep Bhomik, are you listening?
Yes, sir.
Yes, just follow it. What she told, that if we are going to calculate the factorial of a number, suppose 5, whose factorial value will be 120, right? So if we are going to calculate the factorial of a number 5 factorial, then we are going to follow in this approach: 5 into 4 into 3 into 2 into 1. That is the approach that we have to follow in case of our programming or flowchart or algorithm, whatever logical diagram we are going to follow. We can follow this approach, right? So what she actually tried to do, she actually tried to see the approach from right hand side to left hand side, or we can also follow the approach from left hand side to right hand side according to our choice. So if we follow the approach from right hand side to left hand side, then our initial variable will be, suppose I equals to 1. Okay, suppose our initial variable is I, and it should be I equals to 1. If we follow from right hand side to left hand side, try to follow. If we follow the approach from right to left, then our starting variable will be I equal to 1. And for each and every iteration, that I will be incremented by I plus 1. Each and every iteration, after each and every iteration, it will be incremented by I plus 1. And we will take one more variable, suppose P equals to 1. Okay, that is a temporary variable, or you can say an intermediate variable, where we are storing the results of the next step of the factorial. Okay, how? Let's see. If we will do this formula, if we will apply this formula, that means we will apply what? The multiplication operation on the incremental variable I, and the P is our initialized variable, so P into I. So in the first stage, so this equal to mean assignment, I told in the last class that whatever you have done at the right hand side, that value will be stored at the left hand side. That is the job of the assignments, right? So at the right hand side, what we are doing, we are simply multiplying, and the value, whatever it will be generated after multiplication, that will be stored at the left hand side variable P. Or you can say it's more betterly, in more better way, we can say that the old value of P is updated by the new value of P. Okay, why old value of P is updated by the new value of P? Because we are putting this entire process into a loop. We are putting this entire process into a loop. So our loop begins here, right? Our loop begins here. So we will just make P equal to 1 outside the loop. We have to initialize P equal to 1 outside the loop, because we have to initialize P equal to 1 only at once. We should not initialize P equal to 1 twice. And our loop begins here, and our loop ended here. So this is our looping part, which will be repeated multiple amount of time, right? That is the logic of the loop, which I already discussed. So whatever we have written within the loop, that will be repeated multiple amount of times, right? Until the ending condition satisfied. What is the ending condition? The ending condition, I have told that we have written that we can write the ending condition by using the if. By using if. So if we write if here, and if we write I less than the value for which we are going to calculate the factorial. What is the value? I less than 5. Until I less than 5, until I less than 5, not I less than equal to 5, it should be I less than equal to 5, this loop will continue. Okay, this loop will continue. I am just giving an overall, I am not writing any algorithm, I am not writing any flowchart. I am just giving an overall logic how to write the algorithm and flowchart, that you will write by yourself. Okay, I am just giving an overall logic of how to do factorial, right? So I less than equal to 5. So let's start from the beginning again. Okay, this is our example. What is the input of our program? Our input will be 5. The program input or the flowchart input or algorithm input is 5. What is the output of our flowchart or algorithm? Output will be 120. 5 into 4 into 3 into 2 into 1, that should be 120. That is our end result or output of our program or flowchart or algorithm, right? So our algorithm is started with the initialization that P equals to 1. P is a variable, initialized variable that we have initialized with the value of 1. Okay. Now within the loop, we will take one more variable, which we'll call the increment variable or iteration variable, iterative variable, whatever you call. This is actually called iterative variable because the iteration is happening based on that variable. So that's why it's called iterative variable. So this iterative variable started with the initialization 1. Each and every time it will be incremented by +1. Okay, and how much time it will be incremented? Until it will reach the value I less than equal to 5. That means the value of I, until it is less than equal to 5, okay, it will be incremented up to that much of time. When it is greater than 5, it will stop its increments and it will break from the loop. It will go outside from the loop. Okay, so outside of the loop, we will print the value of p. Print p. Okay, because p is our output variable here. So that's why outside the loop we will print the value of p, and that p should contain the final value of 5 factorial, that is 120. How? Let's check it out. So it will enter with the value of 1. It will first enter with the value of p equal to 1. So this I equal to I plus 1, we should do it after p equal to p plus I. How? And why? That we are going to check. So it will enter with these two values, p equal to 1 and I equals to 1, right? With p equals to 1 and I equals to 1, right? Now this loop will continue. This loop will continue until I less than equal to 5 reached, right? So when it will enter with the value of I, what is the starting value of I? 1. So 1 less than equal to 5 satisfied. So it will enter into a loop until it will satisfy that number of time it will enter into a loop. When it will not satisfy, when the value of I is greater than 5, then it will unsatisfied and it will break the loop. It will go outside the loop. So it will first enter into a loop with the value of I equal to 1 and 1 is less than equal to 5. It's satisfied. So the first value of the p becomes p into I. What is the value of p? The value of p was 1. And what is the current value of I is 1. So 1 into 1, what is the current starting value of p? 1. Okay. This I am writing this for your evaluation. Okay. You should not enter this into a flowchart or algorithm. I am just writing this for the rough work for your evaluation. Okay. So p equals to 1. The first value of p will be 1. Okay. Now the loop will again return. The loop will again rounded. Why the loop will again evaluate? Because till now the condition does not satisfy. So that's why the loop will again rotate. Okay. Now the next time the loop will rotate with an increment value of I. What is the increment value? This one is the increment value. The loop will rotate with the increment value of I. So this I equals to 1, we should also write this I equals to 1 outside this loop. Okay. Clear? So p equal to p into I. P equal to p into I. The first value of p is 1. Now I is incremented by 1. What is the current value of I here? The current value of I is equal to 2 here, right? So the loop will again rotate and it will check whether 2 is less than equal to 5 or not. 2 is less than equal to 5 or not. Yes, 2 is less than equal to 5. So it is satisfied. So it will enter into a loop again. So when it will enter into a loop, what is the current value of I? 2. And what was the previous value of or old value of p? 1. So 1 into 2, that means 2. What is the current value or updated value of p? The new value of p, that is 2. So the new value of p is 2. Okay, clear? I think up to this clear. Next time the value of I is again incremented. What was the old value of I? 2. So after incremented it by 1, it will be 3. So it will again check whether 3 is less than equal to 5 or not within the loop. The loop satisfied, 3 is less than equal to 5. So it will again enter into a loop. So in that case, what is the current value of I? 3. Current value of I is 3. What was the old value of p? 2. So 3 into 2, 6. So what is the current updated value of p? 6. Clear? Now again it will increment the value of I by 1. What is the current value of I right now? 4. So it will again check whether 4 is less than equal to 5. Yes, 4 is less than equal to 5. So it will satisfy. It will again enter into a loop. So what is the current value of I? 4. What was the previous value of 6? 5. Sorry, previous value of p? 6. So 6 into 4, 24. What is the current new updated value of p? 24. Now again the I value is incremented by 1. So the current value of I is 5. So again it will check whether the 5 is less than equal to 5. Yes, it will satisfy because equality is there. Okay, equal sign is there. So 5 is less than equal to 5, satisfied. So it will again enter into a loop. What is the current value of I right now? 5. What was the previous value of P right now? 24. The previous value of P is 24. Okay. What is the current value of P? 24 into 5. That means 120. So now if the I value is incremented by 1, what is the current I value? 6. Now again it will check whether 6 is less than or equal to 5. No, it is wrong. It is wrong. This condition does not satisfy. So it will execute from this loop and it will print the last updated value of P, which was 120. Am I clear? Anyone has any doubt?
Yes, sir.
This is the actual logic of factorial, of finding a factorial of a number. Anyone has any doubt? Then you can ask me. Any sort of doubt, you can ask me.
Sir,
One second. Yes, please tell.
sir, in the Fibonacci series, while we will print it, will we take any number such as will we take any number from the user? Then will we print it up to
Just
that?
1 minute. I'm coming into a Fibonacci series. First, tell me if anyone has any problem regarding this factorial of a number or not. Do you understand it? If anyone has any problem, first let it clear. First, let this factorial of a number make it clear first. Have you understood it? Anyone has any problem? If anyone has any problem, you can tell me. So we can evaluate this factorial in a reverse order as well. We can evaluate this factorial in a reverse order as well. That instead of starting from 1, 2, 3, 4, 5, that means each and every time I'm incremented the value of loop by +1, we can start the value of I equal to 5. So in that case, instead of incrementing, we have to decrement the value of I by -1. So the reverse logic we can apply to implement the same factorial of a particular number. So in your examination or in your paper, you can use any one of this logic. Either you can going for the increment operations or you can going for the decrement operations. Okay, both results will be similar, but you have to change the logic accordingly. Okay, you have to change the logic accordingly. If you are using a decrement operation, you have to change the logic accordingly. Okay, so it should be greater than or equal to 1. In that way, we will change the logic. Okay, so this is all about factorial of a number, how to find a factorial of a number. So I think you can right now you are able to write the algorithm and its corresponding flowchart. Now comes into the next part, that is Fibonacci series. So someone is also asking that they are facing problem in doing Fibonacci series. So before Fibonacci series, to solve the problem of Fibonacci series, you have to understand how the Fibonacci series is arranged. If you are able to understand the arrangement of the Fibonacci series, then it will be easier for you to solve it. Now you can ask the question. Who is asking?
Yes, sir, me.
Now who is telling right now? The lady who is
Yes, sir. Excuse me, sir.
yes.
Sir, in the question, as you told that to print the Fibonacci series, but sir, whether will we accept any number from the user and then print it up to that, or else it will go on infinitively?
No. We have to accept. Look, there is no logic of
Yes.
infinity. I have already told in case of algorithm, flowchart, or programming, you cannot do any sort of infinite type of things. It should be
Yes, sir.
finite in number. So we have to give the range from the user.
Yes, sir. I have
Okay.
taken then an input n from user.
Right.
I have taken.
Very good. We have to take the range. If I am going to take the range of 1, 2, 3, 4, 5, 6, 7, 8, if I will take the range of 8, then our Fibonacci series will printed like this. If I will take the range of 7, then our Fibonacci series will be printed like this. Okay. So 7 means total 7 numbers. 8 means total 8 numbers of the Fibonacci series will be printed. That is the input of our Fibonacci series algorithm. The input of our algorithm is the range up to which you want to print your Fibonacci series. That is the input of our algorithm or flowchart. Now, if we look at the Fibonacci series very carefully, you will see, you will find the patterns of the Fibonacci series. Can anyone tell me what patterns you are looking at in Fibonacci series?
Sir, the very third number is the summation of the first two number.
Very good. Each and every case, the third number is the summation of the first two numbers. So if we consider A, B, and C, okay, these three variable for the three numbers. Suppose we will consider it. Okay, so according to her, C equal to A plus B. Okay, C equal to A plus B. So each and every case, the third number is nothing but an addition of its previous two numbers. Not only third number, any number is actually the addition of its previous two numbers. Okay, so it will start from this third one. So if we consider this number, it is also an addition of this previous two number. 1 plus 1, 2. So in that case, this will be C, this will be B, and this will be A for the next iteration. Then in the next iteration, we'll consider this number. This number is nothing but an addition of the last two number, 2 and 1. Okay, so 2 plus 1, 3. So in this case, this will be variable C, this will be variable B, and this will be variable A. Okay, so in this way it will move. This number is also addition of its previous two number. This number 8 is also addition of 5 plus 3. This number 13 is also addition of 5 plus 8. Am I clear to everyone? This is the logic. This is the process that you need to apply or implement in your flowchart and algorithm, whatever you say. And if you will do programming, you will apply the same logic.
So in the logic portion, a little bit problem I'm facing. May I say, sir, as you told that the number that we are inputting from the user will say the range. Like suppose if we print 0, 1, 1, 2, 3, then from user we should get 5, right? Like 5 numbers. So then, so after printing each C, we have to increment some kind of suppose I'm taking one variable such as count, then we will place count plus in every step, and then will we check that the count is equals to n or not, and then if yes, then we will follow.
No. You don't need to do such a complex procedure. Actually, suppose user input. Okay, I am take INP. INP is the user input range. Okay, I am take range, range. So range means the user give his range. Suppose I have given the range here is suppose 1, 2, 3, 4, 5, 6, 7, 8. So my range is 8, right? Now I am just creating a loop here, and the loop will execute until that loop variable should be less than or equal to range. Understood?
Yes, sir.
And the loop variable will be initialized as I equal to 1.
Okay,
And at the end of the loop, we will print I equals to I plus 1. Okay, the same logic that we have already applied in case of our factorial program. The same logic. Okay, so let's start with I equal to 1. So first it will check whether 1 is less than or equal to range. What is the value of range? 8. So if you are getting confusion in range, then you can directly put 8 here. I have no objection. Okay. For right now, you don't need to do. While you are doing C programming or Java programming in future, then you will take a variable instead of direct values. Okay, but right now we can do it. Okay, because this is nothing. This is not a programming. This is simply a algorithm of flowchart like this. So if we are putting I less than or equal to 8, so 1 is less than or equal to 8, condition satisfied. So this loop will run. And whatever process you will happen, look, I am not writing the entire process. Here, 2 more lines needs to be added. That I am writing afterwards. But right now, I am just telling how many times this body of this loop will execute. Until 1 less than or equal to 8, then 1 is incremented by 2. then 2 less than equal to 8, then 2 is incremented by 3. 3 less than equal to 8, so how many times it will increment it? How many times it will repeat it? Total 8 number of times. Because when the value of I is greater than 8, that means when the value of I becomes 9, when 9 is greater than 8, then it will dissatisfy the condition and it will break the loop and go outside the loop. Am I clear?
Yes, sir.
This is the logic, simple looping logic, nothing else. Okay, you can use the counter variable, that is not a big deal, but counter variable make it complex. If we have the easiest solution, why we go for the complex form? Okay.
Yes, sir.
So here C equal to A plus B, C equal to A plus B. So if you remember, let's go back to the first case when the first number is 0 and second number A equal to 0 and B equal to 1 and C equal to 1. So first two numbers we have to print forcefully here. Try to understand very carefully. These first two numbers we have to print in our algorithm of flowchart forcefully, because these two number has no logic yet. Okay, the logic will be started from third number, which is nothing but a summation of the previous two number. So in case of this first two number, we have no logic. So that's why before starting the range, we simply print A, which will hold the first number, and print B. Obviously, we have to assign the value of A and B first. What is the value of A we will assign? We'll assign the value of A equal to 0, exactly, and B equal to 1. So what will be the first output of our program? 0 and 1?
0,
1. 0 and 1.
0 and 1, that has been printed. I have made it a yellow marking. That has been successfully printed after executing these 4 lines. I think it is clear to everyone. Now,
Yes,
in the next case, we will start with the concept of range. Okay, and it will enter with the loop value, iterative variable value, that is I equal to 1. Now, in the next case, C equal to A plus B. So we can print the value of C here easily. Can we print it? When we will print the value of C here, it is automatically included. Are you agree with me?
yes, sir.
Within the loop,
Yes, sir.
within the loop, the
Yes,
first
sir.
value has been successfully printed. Okay, now we have to apply such a logic that same thing will be repeated for all the other cases. That means the summation of the previous two will be created the third number. The same logic will be repeated for all the other cases, because these are the cases where we can apply the logic, except the first two cases. In the first two cases, we cannot apply the logic. Okay, but from the third case and from the fourth case, we can easily apply the logic of the addition of the first two or previous two numbers. So in that case, if you check that if I want to print these two, what we will do? We'll simply change the position of the variable. That means now the C becomes B. Right? The C becomes B. So can we
so
write?
C-
Can we write in this way? C equals to B, and B becomes A. The previous
Yes,
B
sir.
becomes A. So can we write
Yes.
A equals to B? No, sorry, bull liklam. B equals
Sir,
to A. B equals to
sir.
A. B equals to A. Okay. Why B equals to A? Because B was the previous one, and it becomes A right now. It becomes A right now. Okay. So C becomes B and B becomes A. Very simple. So if we will do it, we will check it again. Okay. So our loop ended here. Our loop end here. Okay. Our loop begins here. And our loop ended here. Now, in this case, we can do that. Let's recheck the model again. So first, 0 and 1, I have printed 0 and 1 successfully. Okay. Then within the loop, the first thing is printed is addition of 0 and 1. That is C becomes 1. So C is printed. Okay, in the previous case, while I didn't change ABC position. In the next case, C becomes B. Now, what is the current value of C right now? Can anyone tell me? When C becomes B, the current value of C is 1.
1, sir.
And when B becomes A becomes B, what is the current value of B? Is also 1.
1.
Okay.
1, sir.
Also 1. This is I'm writing roughly. Okay. Don't put it inside the algorithm or flowchart. This is for your understanding. B becomes 1. Now, I equals to I plus 1, the loop will again repeat. Why the loop will repeat? Because I equals to I plus 1 becomes, right now, I equals to 2, because I started with 1. So I equal to I plus 1 means I equals to 2. Now 2 is less than range. 2 is now less than equal to 8. 8 is the range value. So it's satisfied? Yes, it's satisfied. So it will enter into the loop. Okay. When it will enter into a loop, then it will calculate the new value of C. What is the new value of C? The new value of C is A and B, addition of A and B. So right now, what is the current value of A here? Now current value didn't change of A, na? So that I think A equal to C. A, B, C. Now C here. So A, B.
C then became 2.
Yes. As C became 2, but how? It's addition of A plus B. So A becomes 1 and B also becomes 1. Right. Previous value of this one was the previous one. Okay. This one was the previous one. Right. So after changing the position, C is placed here. We are not going to check the C, because C is the new value which is evaluated by adding A plus B. Okay. Now the value, now B becomes C. So B equal to C. The first will be B equal to C. Okay. B becomes C. So B equal to C. B becomes C. Right though? Because B is placed here. So B is now replaced by C. Now A becomes B, because A is replaced by B. Okay, I was doing a mistake in the last one. So this will be A becomes B. A equals to B. Now what is the value of B right now? What was the previous value of C? 1. Right though? So the
Yes.
the current value of B is 1. Is correct? What was the previous value of B? Here the previous value of B was there. So it is 1. So what was the current value of A? It is also 1. So what is the new value of C? 1 plus 1?
2, sir.
Very good.
2.
2. So now in the next statement, we'll print the value of C again. So what was the new value of C? 2. So it has been printed. Do you understand?
Yes, sir.
Yes, sir. Yes.
This is a very good logic. C programmers are doing this logic, nothing else. You are not writing program, but you are understanding the logic. The same logic they will apply on your algorithm or flowchart to write the program, nothing else. Same logic, very much similar, only syntax are different. So next we will evaluate. Next one, after C equal to 2. Now what is the value of B? B becomes 2. B becomes 2. Because the old value of C is 2. So B becomes 2. Now what is the value of A? A becomes B. What was the previous value of B? 1.
1.
1.
Yes, sir.
So 1 will be there. So now our new C is this one. This one becomes B, and this one becomes A.
A.
So now again the loop will repeat. Why? Because I becomes 3. So 3 is less than equal to 8. Satisfy. So it will again return the loop. What is the current value of C right now? A plus B. What is the value of A? 1. What is the value of B? 2. So 2 plus
3,
1 means
sir.
what?
3.
So again we will print 3. So we will get the code value 3. Okay. Now,
Yes, sir.
now the second one, the next one. So in the next one, again C value will be changed here. C. B will be C. Sorry. this one will be B, and this one will be A, right? So here, what is the current value of B? The current value of B is the old value of C. What was the old value of C? 3. The old value of C is 3. So the current value of B becomes 3. What is the current value of A? The old value of B. What was the old value of B? 2.
2, sir.
So current value of
2,
A
sir.
is 2. Now I again incremented by 1. So 4. 4 less than equal to 8. Satisfy. Again enter into this loop. Okay. And now the current value of C will become A plus B. 3 plus 2, 5.
5, sir.
5.
Okay. So in this
Yes,
way,
sir.
it will move up to the range until it will become greater than equal to that range. So you will get the entire Fibonacci series here in this way. Is it clear to everyone? Tell me.
Yes, sir.
Who is not
Yes,
clear?
sir.
Whose
Yes, sir.
conception is not clear? Tell me. If you don't understand, you can tell me. I can repeat it again. Is it clear to everyone? So in this way, at your home, you should try one more series, which is called Fibonacci series. That you will try. I am not going to do it. The similar logic. Fibonacci series. Fibonacci series. Spelling may be wrong. So in that series, 0, 1, 1, 2, 4, 7, 13, 20, 33, okay, and so on. Do you understand the logic? What logic you should apply here? Tell me,
Yes, sir.
any one of you can tell me the logic. What is the logic is applying in case of Fibonacci series?
So addition of the first 3 numbers.
Yes, addition of the previous 3 numbers. Addition of the previous 3 numbers. 1 plus 1 plus 0, 2. 2 plus 1 plus 1, 4. 4 plus 2 plus 1, 7. 7 plus 4 plus 2, 13, and so on. This is called Fibonacci series.
So, swap the value between 4 variables now.
Yes, same logic. Instead of 3
Yes,
variable
same
A,
logic.
B, C, here we will consider 4 variable A, B, C, D. And
Yes, sir.
within the loop, we will swap the values accordingly.
Yes, sir.
Okay.
Yes, sir.
The toughest one, these are the very easiest one. The toughest one is that you are trying to print the non-Fibonacci series. Non-Fibonacci series. That is the toughest one. Okay. Print the non-Fibonacci. You don't need to do. I'm just telling. Who is interested, they can listen. Non-Fibonacci series. That means the numbers which are not present in the Fibonacci series that you are going to print. Right. So what is the non-Fibonacci series? 4,
4, 6, 7, 9,
6,